everybody. My name is Edgar. That's Alberto over there. This is Randy. And the name of our project is called Drum Learning Machine.
Alright, so our design, so the whole thing, our goal of this project was to teach someone how to play the drums without having a real teacher, a human teacher teaching you. So we have our drum kit over here, and the different parts we have on it, we have an Arduino, we have some LED lights that are on each part of the kit, on the hi-hat, the snare, and the kick drum. We also have vibration sensors. Those will be used to pick up, to detect vibrations in the material, to detect when the user hits part of the drum. We're using Bluetooth. We have a Bluetooth transceiver on the Arduino side, and then we're also interfacing with a mobile application. We're using MIT App Inventor as well. And we have different modes. We have demo mode, sequence, and play along. It's kind of our three-step process in order to teach someone how to play the drums. So our inspiration for this, I used to own a piano that it would kind of like have a screen and it would show you a song. You select your song, and then it would basically teach you how to play. So it would wait for you to hit the right notes, and so as you're playing the right notes, you're ending up playing the song. So that was kind of our inspiration, just kind of following through a sequence of notes. That's kind of what we're doing here. Instead of using notes on a piano, we're doing like the beats on a drum. So we're using a kick beat, a snare, and a hi-hat. Those are the main three. So our inspiration kind of came from that. Because we didn't see any of this kind of thing on the market. They have electronic drum sets, but we haven't seen this kind of thing where they teach you how to play. It's more just you can jam out on it and actually use it for concerts and that sort of thing.
So here we have our circuit setup. We have our microcontroller. We have MOSFETs here for the LED strips. There's 3 MOSFETs per LED strip, one for red, one for green, and one for blue. We also have our vibration sensors connected in parallel with these resistors here. We have the HC05, which allows the microcontroller to communicate with the app. And we have our sound effects board that will be explained in a later slide.
Okay, so we needed to find a way to tell the user when to hit one of the parts of the drum kit. So what we did, we used lights, LED lights. We used LED strips, and we put them around the snare, the hi-hat, and the kick drum. Basically, we connected them to the analog pins on our board, and so we could change the colors on them. We use different colors for each part of the drum kit, and basically you assign the values from 0 to 255, tell it which color you want it to light up, and yeah. So basically, whenever depending on which mode you are, but the basic function is that it tells the user which part of the drum kit to hit.
Alright, so these are the vibration sensors. So basically, it's just, we connect these, there's 2 leads, one's like a positive, negative. Basically, this is like a piezo material, so when there's a vibration, when it starts moving, it creates a voltage across those 2 leads. We're connecting one side to an analog pin and another one to ground, and it's a 10-bit value, I believe, so it's doing 0 to 1023. So we use that value later to detect, hey, if it's a threshold at like 100, if you're not hitting it, it shouldn't be moving, so it should be pretty low, like underneath like 20. And so it's creating voltage, but then it's being converted into to a digital value, so like a bit value. And so we just have a threshold in our code, so that once it goes over a certain threshold, it'll say, okay, we triggered a value, it went over because it triggered. So and what you would do is that would say, hey, this person hit this part of the drum kit. So it kind of just waits in a loop, waits for the threshold to be exceeded by this, and then continues on to the next part. We kind of should talk about that more when the code comes up.
Here we have the audio effects soundboard. Now, when you connect this to your computer, it shows up kind of like a flash drive where you can store files onto it. The way that they're stored is they're named in a specific manner. So we saved .wave sound files onto it. So We name it T00 would be tied to the numbered pin that you see there. T01 would be tied to 1. The board also has an auxiliary output for a speaker. Now the way that it works is when the numbered pin is tied to ground, it plays the sound.
Okay, so to control the flow of the program, we decided to use an app. Like Randy said, we used MIT App Inventor to create it. Basically because we didn't have much experience on how to develop apps, so we found that easier to use. And basically, it's a controller. In it, you can select you select a beat that you want to play. When you click the select beat button, it gives you a list of all the different beats that you can play. And then you have a tempo slider, and that one you can select how fast or how slow you want the program to run. And then you have 3 different modes, like Randy said. The demo mode. We'll go a little more into the different modes later on, but basically you can choose from the 3. And we have our connect button right here. We have to, before we can do anything, we have to connect it to the HC05 Bluetooth module. And once you're ready, you have all your settings selected. Just hit start for the program to run.
So here we have the 3 different modes. Demo mode was created to show you how the beat will look like and sound like. So for demo mode, the lights will light up in a particular sequence for each beat, and it'll also play the sound with the light. For sequence mode, the light lights up, but it waits for you to hit the part of the drum set where we're using the vibration sensors. So as soon as it detects that you hit that part of the drum set, the light will turn green and move on to the next step of the sequence for whatever beat you choose. Play along, it's kind of like demo mode, but it doesn't play any sound. It just lights up the LED, and it just continues going. It doesn't wait for you to hit it. It's set at a particular tempo that you set on the app, so you can start off slow when you're beginning. As soon as you're getting the hang of it, you start going faster. And also in the code for play along, while the light is lit up, the vibration sensor is also detecting whether you hit it to give you a score at the end of how many times you hit it correctly. So a correct hit would be you hit it when the light is on.
Alright, so here's a little bit of the code that we have. So this is kind of just an example. That would be like our main loop up there, the void loop, and basically it's just calling a snare function. And inside that snare function, the analog right is just turning this pin on. So this is the light for the snare on the snare. So it would turn on the light, and 255 means turn it all the way on, basically brightness, full brightness for that red. And then right here is the while loop. So this is the sequence mode. So right here the while loop is waiting, and there's nothing in the while loop. So it's really just doing nothing until this analog reads. So this is reading the vibration sensor pin. And then once it gets, so while it's below the threshold, it just stays here. Once it goes above, it leaves that loop, and then does our hit confirmation function, which basically turns it green for a short time, then turns the light off, and then we'll just delay a second. So it's just kind of an example of what each part looks. We had to do this for each one, for the hi-hat, for the snare, and for the kick. That was like those 3, but then in some cases, it gets a little more complicated because if you're doing a rock beat, the first thing you typically do, at least with what we're doing, you hit the kick and you hit the hi-hat at the same time. So instead of just waiting for one loop, you have 2 loops. So it gets a little complicated. So I'll kind of just summarize it. This is our main loop, which is just a rock beat. So it's the hi-hat and kick, then the hi-hat by itself, then the hi-hat and snare, and then the hi-hat. And it just keeps looping and doing that. So here, the first one, hi-hat kick, calls this function. Basically, turns on the hi-hat and the kick lights, and then it will wait for one of them. Well, actually, this one's both of them. So it's waiting for both of them to be hit, and it could be either one. actually we have an and here, because, okay, so I ran into an issue last semester. I had to kind of rethink this, because it's kind of a lot to handle when you're doing multiple, it's like a simultaneous read. So we're checking to see if like the kick has been hit or the hi-hat has been hit. Instead of just doing one read, because for example, if you hit the hi-hat and the kick at the same time, at that instantaneous moment, it's grabbing a high value for the hi-hat if you hit it just right before, and it's getting a low value for the kick. So you can't just use those, because I'm storing them in variables right here. So at that instantaneous moment when it leaves, you have one that's high, one that's low, so it wouldn't actually turn both off. So I had to do I'd call it an average analog read, which basically just took a number of samples after. So I just read it like n number of samples, like 500 times, kind of discarded the ones that were below the threshold, kept the ones that were above the threshold, averaged those out, and then used that value to determine if it had been hit at any point. So that was one of the problems that we came across and that we fixed this time. So this function just handles, hey, we have a hi-hat and kick, and we just need to, when you hit both of them, turn them both off. That's basically what this is doing with while loops and if-else statements.
So here we have part of the demo mode code. Here we just have a simple rock beat. We have a function for each of the beats. As you see right here, it's just turning on the LED light. We have a function called play sound, where it brings that pin on the audio effects soundboard to ground, so it plays the part. It delays for 250 milliseconds, which allows the file to be played. And then we have a function reset that turns off the LED lights and turns off the sound. And it's delayed for the adjusted tempo, which you set on the app. We also have a play along here where it's just the rock beat function. For play along, it's not continuous, so for the other beat that just keeps going for play along, it just plays the beats 4 times. So you have that window to get your score. And here we have different functions for each part of the drums, and what it's doing is that it's turning on the LED light, and it's calculating, it's grabbing values from the vibration sensor to detect whether you hit it while the LED light is on, and storing that in a variable. So at the beginning of the year, our goal was to have the vibration sticks vibrate, so it would be easier for the user to detect what hand to use for a particular part of the drum set. We're going to do this by 3D printing part of the drumstick and adding a battery holder, bits controller, vibration motor, and Bluetooth transceiver. Unfortunately, we ran into more issues than expected and weren't able to get to this part of our design.
Okay, so problems, like I said in the beginning, one of the problems was we didn't have much experience with app developing. So after trying like Android Studio and stuff like that, another classmate told us about MIT App Inventor. So that's why we decided to use. It's a little easier to code, and it allowed us to basically make the app a little better.
Yeah, and I kind of talked about the vibration sensor simultaneous read issue. So that was like last semester I was very flustered because I was working on it a lot. Just like, why is this not working? But then ended up figuring out just kind of, I made a mistake. I thought I was doing something, then I had to rethink it. So that was the solution.
And then another problem that we had was when we get the score back in the play along mode, we do it through Bluetooth. So we send the settings into the board through Bluetooth, but we also receive data back. So one of the problems we had was that we were receiving like basically values that was basically trash, like we didn't need them, we didn't need those. So I worked on the app for a while. I mean, I worked on the app, and then so it took me a while to. I had to basically flush all those invalid values to get the correct the scores to display on the app. And then the cost analysis, we originally had a budget of $600, and we basically spent less than 400. We were able to save some money on like a big expense was going to be buying the drum kit, but instead of that we borrowed it from a friend, so that was a big saving. And then also Randy had some of the microcontrollers that we used to test and to make the system, so we saved money there too. Yeah, so we were able to be under budget.
So, to conclude, we basically have a working prototype. So we have like demo mode working, we have sequence mode, and play along now. We kind of cranked out play along at the very end, like the last 2 weeks. We solved the multiple readings, solved a couple of issues that we had. We did a lot of work on the app with the connection between the app and the drum or the microcontroller through the Bluetooth. Yeah, so like the things that we didn't really get to, we have 3 parts of the drum kit, but there's also in our head, like what we were thinking was you can add a tom drum, and you can add a crash cymbal to just bring it more. But this is kind of we focused on this basic. Let's see. Yep, we didn't do the drums. Yep, and yeah, so that's to conclude. We're just gonna go ahead and do a demo now. So we're gonna connect that.
Use the camera.
Okay.
So
Do you want this? Is it reach of it?
Yeah.
I don't know if you can see everything, but these are just like a welcome screen. Kind of just tells you all the instructions to use right hand for when the red LEDs turn on, and then the left hand when the blue ones turn on, and you use your foot for the kick. So then we go into this screen to connect to the Bluetooth.
Yep. So now it's connected.
So now it's connected. So we're gonna select a beat, rock beat, tempo, and then we're gonna go through the demo first, demo mode of the speakers. Speakers?
Yeah, I got it.
So if you go ahead.
Yep. So that's demo. I think you can come closer. It reaches. So right now it's doing. Did you pick rock beat?
Yeah.
So it's doing rock beat. So the kick and the drum, the kick and the hi-hat happen at the same time, and the snare. So it's just going through that rock beat sequence. Playing sounds using the lights. So that's what it's doing right now. I want to go ahead and stop it,
Okay.
and then
We're gonna go
you can
into
select the sequence.
okay.
Okay, so sequence started, so it's waiting for me, so the vibration sensor is just waiting, so until I hit the hi-hat, now it turns green, goes off, I can do the kick as well, so there you go. Now I do the hi-hat by itself, then I'll do the hi-hat and the snare, and then the hi-hat, and that was the one loop, so it's 4 counts, so it's the hi-hat and kick, like that, the hi-hat, hi-hat and snare, and the hi-hat. So that's the one loop for the whole rock beat.
And then we're gonna go into beat, play along.
So I have to get it out of sequence mode.
My bad.
No worries. Okay, are we gonna do play along now?
Yeah.
Okay. Oh, I didn't have time. So it should be detecting when I hit this one. So
Okay. Okay.
did it give us a score on there?
No.
No?
Let me do it again.
Is it going?
You got stuff.
Oh really?
Okay, let me go again. 1. Okay, go.
Okay, I'm
3,
ready.
2, 1. Here you go.
Oh gosh! I have to do this one. It's too fast.
Okay, let me go.
What does it say? What does it say?
Oh, I see. Last one.
Alright, here we go.
Okay.
Tell me to count down.
3, 2, 1.
Oh, there we go. Alright, switching over to the dot cam, take a look at the app. And then it shows.
Don't click back. Okay. Sorry.
We have to see the score. We're trying to show the score. That's what we're trying to do.
3, 2, 1.
Okay, here we go. Let's see how good I can do. Oh. Oh, nice. Different beat. Okay, that was it.
Okay.
Okay.
Cam.
Don't hit back.
Cam.
Just, yeah, click dot cam on there. Okay.
And there you go. You got a perfect score.
Yes. So right there, basically it'll tell you the total score is just how many notes it goes through, and then your score is how many you got. So while it turns on, like while the lights are on, that's when it's reading to detect. So that was kind of our score. Yeah. So now, Dr. George.
No,
You said, Dr. George said at the end of our project, we have to, if he can learn how to do this, then we pass.
You're doing fine. You're doing fine.
It's up to you if you want to.
Later.
Alright.
Okay, so any questions for the team?
Any questions?